Oh god, this coffee is bad. I gotta finish it though. Okay. So what are we doing today? Today we are experimenting. Well, we're not really experimenting. I mean, we're writing some monads in different styles, or like interpreters in different styles. DSLs? I don't know what the right term is. Yeah, bad coffee is bad, but I need to finish it. Like, I just opened it today. This is the first pot I've made with it, and it was like a gift. So we gotta finish it. I need to make some room here. Let's put this over here. All right. So I think what I'm gonna do is just finish this cup, and then I'll make like a fresh cup with, you know, a good bean, and go from there. So we are on basically exercise 13-18. There's just a few pages left in this chapter and no more exercises. So I think once we finish this, we're going to talk about free applicative, and then we'll be done from this. It's got bad flavor. Like, it's supposed to be a fancy what is it called? Like strawberry cheesecake or something? Strawberry something. And it's just not good. How does one actually make a cold brew? Yeah, it's disgusting. Like, it's not, I'm not a fan. There was one, like, they were like all novelty coffees. One of them was like what did they call it? Like morning grog or something? And that one was okay. But yeah, anyway. We'll deal with it. It's fine. I can live. All right, so no, more. It was grog, and I think grog is like I don't need to do it here. I have this open already. It's like, jeez. Yeah, it was like basically alcohol mixed with water, and it's what, you know, people used to drink because water wasn't sanitary. So that's what it was supposed to be called. But it's, yeah, it was like coffee mixed with water or something. But I don't know that anyone drinks this nowadays, but maybe they do. I mean, if the water is not safe to drink, then you can just stick alcohol in it. So yeah, this one, I don't know if you missed the flavor. The flavor is the problem. It's like strawberries, and it's weird. Okay, do I even use guard in here? I don't think so. Let's get rid of that. I'm pretty sure that I use state in here. Yeah, in Europe, it's much more common to drink espresso, right? In America, we drink the pour over coffee typically. I prefer like that. We call that Americano typically. What am I doing? Right. Okay. So let's review this real quick. So this Koyoneda stuff has nothing to do with what I'm trying to do. We're trying to basically make this pop push thing to build a reverse Polish notation calculator using different styles of what are these? Of custom monads for like creating DSLs, or like managing effects, basically. It's like effect management styles, maybe. So I realized something, or maybe somebody told me this, I don't remember, but Starbucks is like actually a milk company. They don't actually specialize in coffee. They specialize in like milk and sugar. So yeah, I mean, their coffee's fine. I usually get their Americanos as well because it's got less crap in it. But coffee is something that people can be very opinionated about. So that's for sure. Okay, so yeah, this is basically what we're trying to model. So I think what we need is our don't think we need this yet. But what I do need to do is go and just look at the operational style one, and then it should be obvious to me how I think it should be obvious because we did this relatively recently, how this ends up working. Yeah, so over here we're gonna need, not here, over here. Why? Stop it. GADTs. Okay, and then so the first step in, whoops, the first step in, well, that's true. I mean, I know some people who are way too serious about coffee, but you're right. I mean, it's, yeah, it's also something where, like, everyone can appreciate it as well. You know, like if you wanted to talk about like whiskeys and stuff, people are weirdly religious about that. Okay, so step one in operational style is you need to build a GADT. So we're gonna build a GADT called, I don't remember why it's iStack, but it's like an integer stack, I guess. So we'll just call it, I mean, we can use iStack. We don't have this F thing because we don't have to wrap it. So the F is there because we're gonna wrap this in free. So in the operational style, you don't wrap in free, so you don't need this F here. So it's gonna be an iStack, I guess. And we need like a type, so it's an R. And then we're gonna have pop, which is going to be an integer to R. We're gonna have a push, which is gonna be an integer R, I guess. And then we need the done, which is basically pure. Oh, and I need to return these in iStack. So it's iStack R. And I guess this is... How would I do this? Wait, why is that okay? I don't know. I'll have to think about it here in a second. So this is going to be this, and then we also need bind. We're just going to use R to keep the notation consistent instead of A. What's up, Bredor? And Sour? Everybody's here. What's up? S. No. I'm doing this the wrong way. It's RS. Sorry, I'm still like waking up. I know I shouldn't have this problem, but I'm terrible at getting up in the morning. Okay, so yeah, this one fails, which it should, because this doesn't make any sense. But the question is, what should this one be? So like in the book, it's basically like every one of these in operational style needs to return an iStack. So if in the push case, I feel like, let's look at the push code over here. Well, it's going to be in the free style. Oh, yeah. I didn't think about that. Jappy's in my bot, so thank you. Yeah, you guys have much more conversations than I do. My Discord has gotten pretty boring, but that's okay. So should it just be iStack R? Yeah. I don't have a Discord command, but I should make one. I'll write that down. But the link is below. Yeah. Yep. But I should probably have a command for that as well. It would be better. My Discord's super quiet, so if you want to just chill in Jappies, I would probably think that's a good idea. I feel like it's got to be just iStack integer. But that probably, like, I guess it can just be iStack R, right? Because we can just put an integer in there. I'm not entirely sure. I mean, over here, if you look, like, this is unit, but why is this even necessary? I'm not entirely sure. Right, we got push integer R. Oh, that's like a return type. So it should be R. But then how do I actually push an integer on the stack? I guess it could still be integer to iStack R, right? I think. Because I guess I need to put like a unit in here, otherwise I won't be able to do something like this later. I'm not sure. We'll have to play with this a little bit. 7 viewers. How's everybody this morning? My goodness. I don't know that I need the second R, Brador. Because I think that in this case, all the R is trying to do is allow me to write something like this. I think. So, but I'm not sure. Not entirely sure. Like, it may be enough to just write iStack R. Yeah, yeah. So we're doing this book, right? Book of Monads, chapter 13, and it's like all about the different styles of writing custom monads for DSLs, essentially. And so they were just pointing out that you can use Koyoneda to relate freer and free monads. That's what it was for. Like they're isomorphic via a Koyoneda. Yeah, obviously. Okay, well, let's work with this and we'll see what push has to end up looking like, I guess. So again, this is in operational style. You can essentially just write. I keep reading directly from the book like a doofus. So it's going to be like return equals pure. And then we need to work up the stack, basically. Oh, I don't even need to define this. Pure. And then we need to I have these definitions somewhere, so I think that I don't really have to. So hang on a second. We'll close that. I think we're done with that. And somewhere in here, I have this. Probably in here. So this looks not. This looks like final style, I think. That's what I'm working on now. Oh, there's one called operational style. Wonderful. Yeah, so here's the operational style for like the tic-tac-toe. It's like you take a position and then you return something within the same monad, essentially. Yeah, so this is like the you can just write these instances, they're always the same. So we're doing RPN in operational, then we do what, control V or something? Oh, we'll just do T, I guess. So get this. These are always the same, which is nice. Yeah, yep, exactly. So like in operational style, all you do is define bind and you work your way up using the monad. And apparently this like isn't a problem because you're always going to do this stuff in a monadic context, so it's always sequential, basically. So you're not really saving anything by, by writing the functor anyway. Apparently. Okay, so we're done with this, I think. Well, actually, we're not done with that, are we? Maybe we are. We'll see. Okay, so then I think we just start writing those other instances, so we can just split that. This one vertically. And so we need to write basically these things. Yeah, that's a good point. But apparently it's okay. Yeah, as long as they exist, which is weird. Right, like the monad has to exist for this to work. But you're right, it's kind of strange that you're allowed to do that. Maybe it's not strange, but... Oh, well, first we clearly need this line. I know you probably can't see all this code, but it's really like we need to write these functions, basically. I'll try and move this evaluate function up, but this is basically what we're trying to write. Let's see if... Okay, it doesn't want to format those in a... Yeah. First I thought it was inheritance. I don't think... Yeah. I don't know what you mean by inheritance in this case, but this, if we look at its type, it's... Oh, well, that's not really what I want. I wanted this type. There we go. Right. It's really that iStack monad that's making this happen. Okay, so, all right, we need to write this function. But really, we don't have this interpretation the same way that we had it in this case. So in this case, we are writing basically this function directly. So in operational style, you just write the natural transformation, and that's your interpretation. Oh yeah, reverse Polish notations. This is a type of calculator, basically. I can show you how it works once we finish this code, in theory, if you've never seen one. So okay, so we need an interpretation. Interpret. So we're gonna have an iStack R, and we want to make a state integer R, I suppose. Yeah, so I think this has to be push, because how else would I get the integer value to push onto the stack? So I think that's right. And then clearly we need state, which comes from here. And then we can interpret. Okay. Let's do the following. So in this version, we're going to say like, we got to take each of our monads and deal with them. So there's like pure X, which is just, which is just return X, right? We have interpret, bind, I guess it's got to be it's amazing how long it takes me to get like my brain working. So let's do this. So this type is an R to I stack. That's not the same. Oh, do I have this backwards? I do. Sorry. That's probably why. Yeah, I stack R. Wonderful. So you have to interpret X and then use the state to, and I think it's like interpret.f or something. So like, yeah, you first create your state integer R from whatever X is, which I guess this is like just pure. I don't know. I guess it doesn't matter what it is. And then you bind that in state, right? This is the state bind. I can prove it real quick. See, state. And then we apply F to it to get a new state. Sorry, we get a new I stack, and then we interpret that, right? Because this will be an I stack. So that's that one. And then we do basically the other two. So pop takes an X and push takes an X. Okay, and then let's put this back up here. So that's just an integer. Why does this need to be an integer? Doesn't this thing need to return an integer? What does this X do for me? I'm confused. I need to look at the other example because I'm officially confused again. I should stop closing it like a doofus, but you know, we'll get there. So it's an integer 2R. It's not icy. So this is really just this, I think, right? Because a pop should just give me back an integer. I like it. That's a good one. Now, if only, hang on. If only you had some extra power. Which one is this? Joy. Joy. There we go. Oof. Look at that. Look at that. Seriously, stop this. Okay. So yeah, I think we just need to map pop. Oh, but it needs to be, is this even possible? I guess it is. Because all we need to do is get the last piece of the stack, I guess. So it's like do s get, and then we need that safe last function, which we wrote down here somewhere. Oh, I thought I wrote this. Oh, it's right here. Ah. Oh no, this is just an internal pop, that's right. So we'll borrow this function. Something like this, I think. Yeah, I think pop just needs to be this. And really what it could be is this, right? Because it might give you nothing. And then that way I can just deal with this differently. I guess this is where I want lenses. Joe Pan, thank you so much for the follow. Really appreciate that. Also, so this is our natural transformation. I think I would like lenses here, wouldn't I? Because I have this this thing, and I want to apply this put on the first thing, right? Is that what lenses do? I still don't even know. I'm just guessing. It's like you would pull this, you would run this, pull the first piece out, and then put or something. It seems to, yeah. I mean, this is going to be fine. I just need to deal with this nothing case. Although I could just continue to error out, and then it would be like totally fine because I don't really. I mean, like this isn't production code or anything. We just got to deal with this put. So let's just simplify it. We can refactor it at the end if we want. Oh, that's true. That's true. I like that. That looks nice, actually. Yeah. Yeah. Alright, so we'll just leave it like this for now. We can refactor it if we want to. We're almost at the point where I can show you what this does, by the way. So, that's cool. And for interpret, I think we just... we modify. Yeah. Well, it's like, again, once you have it working once, then the compiler just guides you to the refactoring. So that, I mean, that's what my entire life feels like right now. I'm just like, yeah, I'll just refactor it later, no big deal. We don't have to do error. Like, that's what I was saying with the maybe. If we add a maybe in here, we can deal with the error more gracefully. But ideally we don't want to use error there. Ideally. Okay, so we're gonna get an S, and what we want to do is take S and add X. I think that's it, actually. Yeah, we'll get there. Could it match R with... Okay, so this is the issue I was thinking about earlier. Push has to be that. Otherwise this won't work. Yeah, and then again, as Sauer points out, that's a simple section that one can use. And do I need this pure? I don't think I do. Because modify returns unit, if I recall. Push unit equals push. What do you mean? I'm not sure what you mean by that, Chappie. Yeah. Oh, that's okay. To be fair, I don't know the difference. Like a Q always comes off the front, right? More like a Q. Well, I think that I guess it's more like a Q anyway. What's the difference? So, what makes something a stack, I guess? Out, content in. So I think it's like a stack because it's a Polish, it's a reverse. Let's see if I can find like a app here. Calculator.org. Does this work? You give me buttons? No. Could you app Google Play? No. Is there seriously not a freaking RPN calculator? Yeah, so I think it's supposed to be a stack because we're doing RPN. I want Z. I see. Okay, that's actually very helpful. I want Z, so it is a stack. So you're saying this doesn't behave like a stack? Oh. Does that work? Yeah, I think Altern is right. I think I did have like a. Wasn't I adding it at the end? If I did plus plus x in list? If I did x plus plus, then it would have gone into the front. But I'm pretty sure I was adding it at the end. But this is faster. Well, supposedly. To be fair, I haven't tested it, so I'm gonna say supposedly. Yeah, okay. All right, so let's see if we can get this to work. What else do I need? I keep closing that. Why do I do that? Seriously, being stupid. I'm a dum-dum. All right, so then there was this like optimization thing, but I think what all I need to do is write this RPN thing. And it's probably exactly the same as this. But we don't have evaluate anymore. We just have interpret. Oh, but that takes an I stack. So I need to create. How do I create the I stack in this situation? Do I just pure it? Maybe. So if null s wait, how does this do anything? I'm not doing anything. Right? Like I do need this. Otherwise this isn't gonna work. But I don't have Does this really just work? I'll be amazed if this just works. Is this really gonna work? There's no way. I don't believe it. Okay, we'll find out. The hell is that? Lib iServe. Oh, I don't have a lib function. Dir. Okay, so in operational. All right, so for those who wanted to see how this works, I think what we do is you write like RPN, and then we need a list of instructions. So I think it's like number, I don't know, 1, number 2 plus. And so basically you start from the left and you work to the right. So you can do something like the following. Number 4 plus times. So this will add these numbers together and then add these numbers together and then multiply them. So that's how RPN works, if you've never seen this before. Is that right? 7 times 3. That's not correct. So it's broken. Very clearly broken. So we're gonna have to figure out why, but that should be 21. Well, there's no parentheses in RPN, right? That's the whole point, is you forego parentheses. But, you know, there's probably something wrong with my logic. I'll have to figure out where. Tim Frund, I'm gonna guess that's how you say that. Thank you so much for the follow. Really appreciate that. We're at 187 followers. Very, very close to 200, so that's pretty cool. But yeah, clearly we broke stuff. But I don't know what yet, so... I can't write that. That's nested. Like, that's not possible. It's not list of RPN, right? Not with that attitude. Well, okay. That's probably true. All right, so maybe what we start to do is what? Oh, well, this is wrong. Right? So this S is really the beginning of the list, and this is the final one. What you need to do is put XS. Oh wait, I guess I just had them backwards, so actually it was fine. But anyway, this is really what we want. Let's change this to V, I guess. All right, so if we have a number, we push it onto the stack and we continue. if we plus, we pop two numbers, add them together. How does pop work again? Pop should return an integer. We push that onto the stack and we continue. I mean, looks right to me. This is not right. This is putting it on the front. This means, you know, something like the following. This is supposed to be this. You guys strayed me incorrectly. That's not on the end. That was X colon S. That's on the front. Right? Yeah, I blame you, Sour. You created a bug. No, it's fine. But no, that's on the front. So I need to put this on the back because I'm pulling everything off the back. Now, ideally, if I switch my code to pull everything off the front, then that would work. But currently, the way it's written, pop is written such to take things off the end. So we could take stuff off the front. But let's do it this way and see if it just fixes that bug anyway. Okay. Ah, shoot. Reload. There you go. So yeah, we are taking stuff in the wrong order, basically. So it was like when we were pushing onto the stack, it was happening in the wrong way. It did. I don't know what it did exactly. I guess we could trace it very carefully, but I don't want to. So let's do some I keep screwing up. Lumi would be so mad at me. Was Lumi here? I haven't seen Lumi yet. So hopefully he won't be mad at me. All right, so let's modify this code a tiny bit to see if we can make this better. So our interpret function errors, which sucks. We don't want that to happen. But how do we deal with that with maybe? Don't summon Lumi. I don't want him to be mad at me. I'm too tired to get the correct order of things. So like Lumi always points out when I save and close and reopen all the time, because that's what I do over and over again. And what I should be doing is, you know, putting things in the background and then foregrounding them. Guys, I'm gonna spit my water out. Chill. Lumi, I've been very bad today. Very bad. I keep saving, closing things for no reason. It's been bad. Okay, so let's change this to pop off the front instead of the back. And then that way that changes this code to yep. I'm screwing up. So all this does is change the following. This becomes tail, and this becomes head, basically. And then this does the exact same thing, basically. So if we do it this way, that will be the basically what Sour wanted to do, more or less, right? It just makes this a little simpler, but you have to flip the logic in your pop function, otherwise it won't work. So I think that this will work. Yeah, see, like I could have saved the state that I had there and then just did R, but now I have to do M import RPN in operational, and now I can do this again, and that should give you 21. Yeah. So anyway, I had a I don't know what the right term is, but it was a stack pulling off the end, and we wanted to do Sour was interested in doing the stack from the front, I guess. I don't know if there's one that's better than the other, but that's basically what it was. So yeah. Okay, so we need to deal with this error because it's not very nice. And then also, Altern pointed out that our minus operation may be incorrect, so we need to figure that out. Yeah, but I need an actual RPN calculator to do that, I guess. Does anyone know an RPN calculator on Linux? $2015. DC. What's up, day by day, by the way? No. There we go. And DC. Oh, this does RPN? Oh, I see. It's just a revert. Nice. So we can do, let me see an example here. I'm just trying to remember for RPN where the minus sign ends up. So that's all. Do I just do it like BC? Guess so. So it would be like 1, 2, minus. How do I run it? Entering a number pushes it on the stack. I see. So I have to do 1, 2, minus, enter. P. So this is, okay, so it sticks it right in the middle. Wonderful. So I should get -1. So we'll see if mine's right. I think it's right, but yeah, I've never used DC. I've used BC, but never DC. It's like Ed. Okay. I've not used, yeah, the standard text editor, right? I've actually never used Ed either, so. Okay. Yeah, so I don't think we actually need to reload, but we just need to make sure our negative works. So I think I wrote minus or subtract. Yeah, so this is the wrong way, basically. Yeah, so the cue that I was writing, Sour, oh, here, I can just show you real quick. The cue that I had before was taking stuff off the end. So the pop function didn't match the push function, basically. So all I did was I put this as plus list of X, and then it was fine. But then we just flipped the logic so that it was push and pop matched. That's all. So our minus function isn't correct because we need to actually do this backwards. So we could just flip, and then it would be fine. Very true. Very true. So if we just flip the minus sign, I think that will fix our subtraction problem. And also, to be fair, they don't ask you to implement subtract, but I was trying to add something really easy. Or I wanted to add another operation. But right now, the way this is set up, it always takes 2 operations. So there's no... why can't I think of the term for single... I guess it wouldn't matter. I could do single pops. Unary. Thank you. I could not think of that. Oh yeah, flip is amazing. So like we don't want to... We could write this code to, you know, pop both the things and then put them together in the other order, but we can just flip. It's great. And yes, we don't have any unary operators, but we could, I guess. Yeah, so what Jappy just put in chat, that's basically flip minus. Same thing. Well, effectively the same thing. Yeah, so that should fix that problem. And proving, there we go, right, -1. I don't think anyone was surprised by that, but, you know, I'm just pointing it out. And I think... Oh, wrong one. Sorry. That's the... So the only other thing I want to deal with is figuring out this maybe piece, because I don't... Obviously, this sucks. So what do I do? We can't pop nothing, right? Like I have to return an R. So the only problem is everything has to operate in maybe, right? Like iStack has to be maybe R. I think. Well, no, it has to be. There's no other option. So I think what we can do is just change our interpret function, our evaluate function. Well, we have to change everything, basically. The question is, does it need to change up here? I don't think so. Like, do I want to change the data type or the interpret? I don't think I want to change the data type. I suppose we could just stick a 0 in there, but like, couldn't that be... Couldn't that be confusing for users? Yeah, I think that's what we want, Jappy. I think. Like if you try and pop, if you try and write plus, that would just give you 0. I agree that maybe complicates the code, but I think Strager's point is like, well, if we just put 0 in there, we could get plus. Well, let's try it. Let's see what it looks like. Because I think that you could literally just write plus and it would just give you 0. And that would be probably confusing. But I'm willing to try it. Let's see what it ends up looking like. Oh, but this isn't gonna work. What we can do is do the following. Yeah, that's not gonna work. Yeah, so we can't actually stick the 0 in here. Oh yeah, we can. I think. It's only going to store integers anyway, so that should be fine. And the compiler seems to be okay with it. Okay, so now if we do this, yeah, pop returns an R, but the only valid R is really an integer anyway. I'm not entirely sure. That's the style. To be honest, I'm not sure why you make it polymorphic. Like, I guess I don't make it polymorphic here and here, right? I think it's to make these happy. Right? If you don't have a polymorphic R, you can't use these, I guess. Is that right? Because it's monad I stack, not monad I stack integer. It has to be polymorphic in R. Oh, you're talking about a different R. Yeah. Which R? You're talking about just this R. Oh, I see. Just here. Yeah. I mean, this could just be integer, clearly. Yeah. It doesn't have to be polymorphic, but I wrote it that way. You're right. So what was I going to test? Oh yeah, I wanted to see what happens when you do plus, because I think that it's just going to give you, I think it will work, and it will give you 0, which is confusing. Potentially. Yeah. So that is confusing, I would say. Like, to a user of this program, not that there will be ever any users to this program, but yeah, I can do that. Oh, just everywhere. Yeah, I don't want to do that. That's scary. You also don't need the V, I suppose. Anyway. Ow. So do we like this? Because I feel like this should fail. Right? This is not a valid RPN. So I think what we really want to... Yeah. Wait, we don't... Chad doesn't like what? Chad doesn't like this? Or the... I mean, we can change the other code. Here. Here. I'll make you all happy. Okay. Yeah, I don't think returning 0 is the correct thing here. I think that we need to return some sort of left. We could return either integer or an error message. Yeah, that's what I think so too. So, and yeah, it only needs to be over here. It actually does not need to be here, because this will give you the thing you need. It's really just in the interpretation function that we need to deal with this. So this is just return dot just interpret dot just no wait a second. It is going to be annoying. But it's the correct thing to do, so we should do it. So the thing is that this returns this, and so what we should do is just f is going to return. What's up, Skybro? How's it going? Yeah, that's true, but I think we can still do this, right? So this f is that's not right. Yeah, I think you're right. Yep. I think you're all right, unfortunately. Isn't it? It's not maybe. I thought it was except T. Or is that the either version? Okay. Anyway. So we need... Which one is it? I'm now confused. It's this one. Yeah. Okay. Salespeople like to promise things. Oh, monad I wrote. Dur. Alright, so then this is going to be maybe T... How does this work again? The monad is going to be state... Like that? We're not doing arrows. Yeah, I think the maybe is supposed to be embedded, right? Because it's supposed to be in the return type. So it should be state T on the outside, right? I don't know which way it's supposed to be, like, logically. This says the whole computation can fail. Right? Well, yeah, we need lift, but the interpret function needs to be right first. So this says the whole computation can fail, and the other way says some of the computation can fail. This is better because you don't need parentheses. That's fair. All right, we'll try it both ways, maybe. See which one ends up cleaner. It's the maybe goes in the middle, if I recall correctly, for state. I think it's like this. I think I still need... Oh, right. Okay. Okay. I see what you're saying. Yeah, yeah, yeah. Yeah, 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 yeah. Yeah, 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 yeah. A good way to put it. Okay, let's see if we can figure this out. So with maybe T state integer, you have access to the state on failure. Yeah, I think you're right, Strager. I actually do think you're right, because you want to say, like, I want to be able to pull out the state at the end. So I think Strager's right. Although that's the way my brain is working. Yeah, no, it might be the other way around too. I'm not even sure. Because it's like the inside out thing. So like your brain wants it to be, I think your brain wants it to be the way Straker said, but it's actually the other way around. I don't know. But I think it's supposed to be this one. Let's work with this one. So what does this mean? Chat is going off. I like it. Okay, so it just seems happy? How can it possibly be just happy? Oh, because I haven't dealt with any of the maybe stuff. State D add state to some other monad would add failure or success to some other monad. Meaning the whole thing could be nothing. Right, so Skybro, I think what Skybro is saying is the way to think about it. Right? Because if the whole thing can return nothing, then I don't have access to the state. But if just the... Yeah. We're going to have to fix that here in a second. But I think the way Skybro is saying it is probably the right way, which I think is also the way... But I think that's... Yeah. I'm not entirely sure who's correct. It's either Strager or Skybro. We're going to have to find out, I suppose. The question is, do we have access to the state when we're done? That's the real question. The nice thing is no matter what, this doesn't need to change, so that's kind of nice. So really, this is going to either return something or nothing, right? So it's going to return a pair. So we'll just say P. And I guess... But I don't want to do it. Yeah. So if, I mean, we're either going to get just or nothing. But I always forget, like, if I just do case here, like, I can just do case. Let's just do case for now. Of excess v but this is not... It's hard to follow chat right now. That can't be right. this needs to return an integer. Lift what? That's what I don't understand. What am I lifting? How do... Like, I mean, this can't be right, right? Might be right. I don't know. Of course it compiles. Damn it, Chappie. Please show me the type. Is something broken? What? Oh, something is broken. Okay, that's fine. I was like, why won't it show me the type? So seemingly that's compiling. So what's the problem with this now? The problem with this is that we have a maybe to deal with. So it's okay, so it's lifting the A. Right. So when I run state now, I'm gonna get like I need to like case on this whole thing, right? I just want this to compile and I'll think about it in a second. Yeah, see, okay, so here's the thing is that we don't have access to the state, right? I think I just need to practice. So we don't. Oh, right. Yep. But this isn't gonna work. So does this compile? No. Oh. Just anti-productivity tools? Is that a meme now? What is anti-productivity tools? Strager, when do you stream, by the way? Do you have a schedule on your page? I'll just look at it if you have one. You don't need to tell me. I think I've watched you a few times, but so can we still get access to the state? No, right? Because it's either gonna. So we did want maybe T. I think we wanted maybe T on the outside, right? No, you're right. I only have I have the state, but only in the case where the computation works. So I don't know what the stack is. Like, I can't tell you anything about the stack. Like, what the stack was when it failed. And that's what we kind of want to do. Thought that was the point of this whole thing. How do I do that? Maybe I don't use run state T. I just, yeah. I think Strager's got it right. I think we all got it wrong. I think the maybe needs to go on the outside. And it's like this inside out thing confusing me double time, basically. But how do I get access to the state if... That's what I thought too, but maybe I'm just doing something wrong. Like maybe... maybe I can pull the state out. Oh. Stack will be empty. Well, no, it won't be empty, right? I want the instructions. Man, I think I'm just being stupid. If I just pass the instruction, like just print the instructions, that's actually what's failing. It's like what's left of the instructions. That's not the same as the state. So, okay, yeah. So I'm thinking about this completely wrong. So when we fail, I think what we want is like a writer. Yeah. The way I have this written is not possible to get what I want. What I really want to write is what's remaining of the instructions. Maybe. Yeah. I think we actually want a writer or something. But I think we're getting way ahead of ourselves. I think we should just not worry about it that much. Like, because it's not that important, essentially. Like, we're not writing production version of RPN calculator, so let's not worry about it, and we'll just do this. Ooh, excuse me. Can I just derive show from this? I feel like I can. Okay. Sorry, this is hard to read for me. Then push 0, else push 1. How would you get the push 0 or push 1 instructions if the pop fails? Maybe I can't. Maybe that's true. Production RPM, yeah. Okay. Anyway, I think what we can do is just say, like, look, these don't terminate. It's better than error. We've at least pushed we've pushed the error to the edge. So that's a win, right? I think that's a win. I don't know if it's a win. Seems like a win. So I think it's a win. I don't know if it's a win-win-win, but we sort of tried to do the functional core imperative shell kind of idea. So that's kind of okay, I guess. I don't know. All right, so with all of this, the whole point is that this is called operational style. So you're welcome. You learned something. And in operational style, you basically you use this bind function of a GADT to deal with the recursive nature of your calculations. So yeah, it works fine now. Yep. And it's not ideal. Like I suppose it could be better, but I don't know how to make it better without adding more complication to our interpret function. Yep. Yeah, it's right here. It's pretty easy. It's not that hard. Okay, so I see. Interesting. Famous last words. Okay, so we're actually done with that one now. So now we're gonna do, I think the other thing we need to do is in the freer style, if I recall correctly. Oh, it does say implement optimize, but I'm not going to do it. I think he meant maybe T. I think. Maybe I'm incorrect. All right, and then so we'll so I think we'll use so we need to write some instructions, I guess is the idea this time. So we also need to get this type, I guess, but I don't really want to have this pure dot thing, so I'm just gonna copy this for now. Or pure prime thing. Um. Oh. Hello. There you go. 4. Okay. All right. Yeah, sure. We need these things. And we also need what do I need? I don't really need anything else, do I? I need to write some instructions. So we're gonna have I stack where? I stack R pop So it's just, okay, and we should call it like an I guess. And it's just going to return the things I need. And one of them is going to take an integer. So pop is going to be I stack integer, I guess. And push is going to be integer I stack R. Something like this, I guess. And for reference, these freer pieces would come from a library, so you don't need to write these. I think it's literally called freer or something. Freer simple, maybe? Maybe it's here. I don't know. There's a few different. Anyway, I think it's there. Okay, so unfortunately, I guess I just need to make my interpreter now. So actually, this is supposed to be I stack I, right? I stack I. And then what we make is a data I stack equals freer I stack I. Oh, thank you. That's, yeah. Thank you, thank you. Duh. And then it might save us. I'm not entirely sure yet. So then we need our interpret function. Guess. So that's going to be I stack state t integer maybe r. I can see just like I can read the screen just fine, but they basically have like prism in them, so it just bends light into my eyes. My eyes are lazy, essentially. Have I written one of these before? I don't even know. I mean, I guess it's gonna look something like RPN in free, right? So let's get this one, I suppose. Yeah. I need prism in my eyes. Well, in my glasses. Otherwise, yeah, my eyes don't work right. I see. So we have to write our interpret function, which is basically going to be exactly the same. It's just going to have less stuff in it, and then we have to write a wrapper around the pieces. Okay, I get it. And that wrapper is basically just going to be the same as before. I stack I R. And then we need a pop, which is just going to be a... Well, it's going to be exactly the same as that other implementation, but... Yeah, no. I'm not going to write that again. I don't want to. Why is this not in alphabetical order? It's kind of weird, isn't it? Like, it's going to be exactly this. It's just going to be interpret prime, I think. Because Vim? What? I don't know what that means in this context. I know that there's Twitch flame wars for Vim, so, but that's fine. I guess they're not that bad. People are mostly silly about it. Oh, I get it. Okay. I see. I get it. Is it going to be Strager Emacs? Because that would be pretty funny, I suppose. I don't know what the... No. Okay. Are you an Emacs user as well? Oh, right. Pop is just this. No, it can't be. I'm a Vim alpha. Okay. I'm not very good at Vim, clearly. I wish I was better, but... Oh, yeah. That's just unit. I mean, I've used Vim for a really long time, but I am not a master by far. Like, I've used Vim for like 8 years, but I don't practice, so I've gotten a lot worse. Like, probably, I don't know, 4 years ago, I used to actually care about how good I was at Vim, and now I don't, so I've gotten really bad at it. Yeah, I wouldn't call that leisure, unfortunately. So why do I even need this R again? I don't even... Oh, right, to do the natural transformation. Like, I don't even use this R. I mean, I guess it could be... You could write iStack R here, because this would represent any stack, not just an integer stack. But then it's going to complain down here because I need to write specifically integer, which is probably fine. But then it's not an I stack, it's just a stack. I don't know, man. I think this is like fine. I don't really care. I mean, I should care, I suppose, but it's not that bad. I think this is okay. So this expects an integer. So what did I do wrong? Yeah. I think it has to be the way it was. That's kind of the point. think that's part of the point anyway. Yeah, I think it is part of the point. I think it's part of the point. Otherwise, it won't compile. Otherwise, you can't do, like, because these are happening sequentially, the R in these cases are actually different things. Right? One of them is unit, and one of them is... Wait, no, that's not right. Is it right? For iStack, it is. For R, it's always an integer. No, it has to be the same. My head hurts. Yeah. But then, isn't the iStack, isn't this R supposed to be integer in the modify case? No, it doesn't have to be, because it just takes an integer. Never mind. Yeah, okay. No, I'm fine. I thought my head was exploding, but it's not. I just need more coffee. And I smell it behind me. It's coming. And it's going to be good coffee this time, so that's exciting. Okay. So anyway, now we have this sometimes I have to check. So this time we're going to have our interpret function, which I guess is going to be iStack to this type. And this is going to be like this one, fold free. But I think I implement fold free in here. Where does fold free come from? Final initial free examples. So I think I need to implement fold free for freer. Is that the idea? Probably. Because this is actually free. Skybro, subscribe to tier 1. Not even Twitch Prime. Thank you so much. Appreciate that. Super nice of you. That puts us at 7 subscribers. Look at us, moving up in the world. Moving up in the world. Sorry, I lost my train of thought. Thank you. It's hard, and it blows my mind all the time. This one, fold free. So I need something like this, I guess, for freer. I need to put like something here. Is that right? I think it is. This requires rank n types, and we're gonna say freer, pure, impure, xf, I think. So we have our interpreter, and we have this f. What is this f again? It's just... Am I supposed to apply f to this x and then continue? I suppose this is probably right. Because this is the unit of recursion, right? But it seems like this can be written on one line, right? Like, I don't think this needs to be... I think it's probably fold free, interpret... dot fmap interpret x. Do is considered harmful. Oh, that's actually a thing? Yeah, that's actually a good question. Good question, Altern. I want to name this something different because I don't like... I feel like this is really close. Thank you. Well, I think he's asking you because you had, like you made the point that the operational style is good for, like, I forget the exact words you used, but sequential DSL or something. Is that what you said? It's somewhere up here. Where'd it go? Pretty sure it was you, wasn't it? I don't know where it went. I lost it. Yeah, so that's right. So it would work well in any case that operational works well, I suppose. Right. Because it's like the natural extension. Mm-hmm. That's right. Thank you for reminding me. I drew a picture about this actually because somebody asked, like, what's the connection? And I forget, I need to look this up. This was something that so it's like you have all of these different styles and they inform one another in a certain way. I don't know. It's not something you say very often, maybe. So it's like the initial style informs the operational style, something like that, and free informs freer, and then there's like this natural connection. But I don't remember exactly where the final style fits in. And the other thing is, like, this side requires a functor to give you a monad, but this side does not. Something like this. This might not be like actually completely correct, but it's relatively close. And somehow final style fits in here, but I don't remember how. I wanted to try and implement oh, nice. I wanted to try and implement the final style version as well, because people seem to like this style a lot. I don't know what's so fancy about this style compared to operational or freer. So I wanted to write this calculator in like every style to see what it looked like. So we've done it in initial style because we have the free. Yeah, so final style I think is very popular in Scala, for example. Like, people use this a lot. I hear people talking about it on the internets. So, I mean, maybe that's a good thing, but I don't know how this fits in this picture, but I think that this picture is approximately correct, given whatever these arrows mean. They're like extensions of these things, something like that. Anyway, we'll come back to that. Okay, so what did I do here? I broke stuff. That's what I did. So let's look at this again and then make our mind work correct. So we need to apply f to x prime. and then continue our folding. Isn't that what I wrote? Oh, maybe the key is the parentheses around in fold free. Oh, okay, I see you're using bind as well. That could be right. Oh, yes. Yes. You're 100% right. 100% right. I think you got it. I think it's just this. I think I was just being stupid. Yeah. Oh, this coffee is delicious, by the way. I don't remember what kind it is, so don't ask. I mean, I suppose I could get up and look, but yeah. Yeah, tagless final is what people tend to call it. I'm not going to click that link, but too long, didn't read. Yeah, but we'll try and implement this in final style as well. And then, like, what I wanted to do is compare and contrast all of them. But it may be that, like, we've already essentially written final style. Okay, so with our fold free, I guess all we need to do is write fold free interpret prime, and then we yeah, it would be. I think that's probably correct, probably right. I'm a sucker for good names, so I think you're right. And then what? We can probably just go get our evaluate function from actually our evaluate function changes, doesn't it? Yeah, because I need to I see. So our interpret function becomes very simple. It's just we have to change our evaluate function, I think. So we would just use, okay. So we need to modify this thing, I think. And we're gonna need this as well. So we'll just copy all of this. I know I shouldn't copy this much code, but again, we're not in production here. We don't really care that much. Sure, you can go here. I don't care. Yeah. All right. So I like it. What needs to change here? Is this really supposed to be iStack or iStack I? I guess it's supposed to be iStack. And do you just basically pure everything? Right. Okay, I can deal with that. So these are the instructions. The instructions are push and pop. So those are the impures? I guess. But what F do I use there? Yeah, it's just that I need to incorporate pure and impure somehow. So like this is essentially correct, but I need to deal with the impurities. Or I'm not sure what the right terminology is there. We'll say impurities. But my guess is that this is like impure pop pure or something. So, okay. I was going to guess it was going to be like impure push N evaluate. I thought I was going to guess this. And let's just get rid of these errors. Oh, I need to do with R, so I guess it's at least gonna be R. No, that's... I think you got it. Impure N. I mean, I'll try yours, but I don't... Push. Yeah, these aren't instructions. But you could do pure. Oh, it's not X, it's N, dear. Maybe it's like this. So this can't be... This needs to be another impure? Once we get the right shape, it'll be easy. I don't... What if we just, like, delete this? Does this compile? Okay, it doesn't. So that's, I suppose, good. Because I think that it's supposed to be... I think it's supposed to be push N and then something. Yeah, it's supposed to be like bind, exactly. So maybe? Because push returns nothing, you just evaluate? Maybe? Seems funny, but... Oh. Yeah, I mean, that's actually a good point. If I put a hole there, it might have been more obvious. Because this is just going to be unit, actually. So it's really, I mean, this should compile as well, right? Yeah. Because push returns unit. So, I see. So this is literally like bind, but because of the shape of evaluate, it you have to explicitly write it as a lambda. That's interesting. Well, we need at least plus. So plus is going to be impure this thing oh yeah, that would work. That would work. Nice. I like that. Okay, so you don't like that? I mean, it's the same thing. I mean, I do like that if you write unit, it's explicit, but because that's actually the only value it could ever be. Yeah, I mean, that's fair. I'm fine with either, honestly. It looks fine either way, but I mean, this is the only thing that can ever happen. You can only ever get unit, so. You guys in that little meme. So our instructions are this, and we need to push this thing. Oh, you think so? Maybe. Maybe that's right. I thought that I could probably just... Oh, right. Okay. I think I see the nesting. Because you have to do this, and then you get... Wait. You push, and then you... Continue? Weird. Sometimes I forget we can use impure as that. Sorry, I'm just trying to understand what's going on here. Infix is the term I'm looking for. Yeah, let's see if we can write this way first, because it seems like we should be able to. But I think that it's actually not a nested. I think it's just a monad for I stack I. Oh, that's the impure thing. Yeah, I don't know. I don't know what this is. So impure takes basically instructions. So that's this. These are instructions. Let's try it. Let's try it this way, I guess. This is going to give you like a value. And then you need to continue. So to continue, you're going to push n. No. This is hard. This creates more instructions. Maybe? Needs Lisp. Oh, my head. Okay. Holes. Okay, so step 1. This code doesn't work. Where though? What are you talking about? Here? This is what you want? To the bottom. Yeah. It's complicated. It's very complicated. That's why I'm having a hard time wrapping my head around it. So what is this? What is this? All right, I know what time it is. We need some help. Okay. So this is an I stack I. So this returns a thing. So it needs to be put in an impure, right? Impure this thing here. Oh, well, impute. That's not the same thing. Right? No, this doesn't compile. Right. So this actually needs way more crap because pop doesn't have applicative. Only the freer version has applicative. Fun. Yeah, so I see what you're saying now. It's like, I think having little functions might be easier. So we'll just write the little functions, I guess. So this needs to return a stack, an I stack. What is it? Yeah, I stack. I stack R. I mean, but these are just those functions. Oh, but okay, never mind. Yeah, yeah. Yeah, I think you're right. What does this need to be? I need to make an I stack. We'll get there. So this is no longer instructions, right? So I see what you're doing there now. Okay, so these are like... I vaguely remember them saying, them as in Alejandro, in the book, saying that at some point you want smart constructors, but I don't remember him pointing out you want smart constructors in the the freer style, but it does seem like they're gonna make life a ton easier. Online. Oh, it looks like I did that. Okay. Yeah, that was the term that he used for them, is smart constructors. But I didn't think that this style was one that needed them, but I think dealing with this impure stuff would be really problematic without it. Okay. Then what was the next thing you wanted to do? We wanted to, well, let's make sure this works. But it seems like it should work. The cool thing is that this will never change. Like, once you have the natural transformation, you just write this function and then this RPN, no matter what version you're using. Yeah, I think so. I mean, I agree. I think you want them, but I don't remember him stating that you want them. You know what I mean? That's all. I don't know. That's just the term that he used. I'm pretty sure it was smart constructor. I don't have a. I would just do a text search, but I don't feel like doing it by eye. Yeah. But these are essentially just like the natural transformations from the iStack type to the iStack, or the iStack I type to the iStack type, something like that. They're not really natural transformations. That's not the right term, but yeah, he has a PhD. I think in computer science or something. Serrano Mena, I think is the right name. I don't know. Anyway, that's who it is. Okay, so what was the next thing we wanted to do? We wanted to try and use some sort of folding operation, but we like map m to well run the program. Sure, we can run the program. Don't yell at me, man. Jeez. That is what we want to do. All right, so we should just be able to, like, we had a longer example somewhere here. What makes it crappy? Okay, that's right. And then, oops. Oh, did I not implement minus? Oh, I always forget that I call it that. Yeah, what makes it crappy? Like, spaghetti's delicious, isn't it? Two minus one. Yep. Wait, no, this isn't right. It's supposed to be -1. Okay. right? We decided it's supposed to be -1, which I guess implies that you just don't flip it, but then that seems incorrect. Oh yeah. It's my girlfriend. City Spaghetti. City Skylines. That was the game you were playing, right? Yeah. Yeah, it is Pog. She's pretty great. Yeah. Unfortunately, I don't really have like a man cave, if you will. We just have a guest bedroom with a computer in it. I mean, let's see if this works, but I can't imagine that it's gonna work. It seems like it... Yeah, that's like a thing people say, right? Having their own little space. As a man. I don't know. I don't really care if I have one. I mean, I could set up in the basement, but our basement is horrible. What am I doing? Oh, right. Losing my train of thought. I need to procrastinate. More or less. So now this is really interesting. Is your basement is bad? I don't think so. He said it was good. Yeah, I'm super confused about this. Why does flip go away? It probably means I did something wrong, right? Because, like, as far as I can tell, this hasn't changed. We pull a value off the end, or the beginning, excuse me. That's what this is doing. Ooh, maybe not. Good call. It's entirely possible. Clearly, something's defined incorrectly. And I did implement these myself, so maybe it's supposed to be KFA or something? Maybe I have these backwards? Let's see if it compiles. I don't think it will, though. What's up, Warren? How are you? I mean, I can't imagine any of this is backwards, because we played with this a lot. Like, this broke my brain. I mean, this can't switch. We definitely tested that. I don't know how to test, like, oh, test the instances for lawfulness? I mean, we could, but it's going to be really hard. Because you have to generate functions, and generating functions means co-arbitrary. And that's always confusing. I looked at that. We can double check it, but so like we do tail and then head, right? So we get the first thing. So that's popping off the front. And then if we pop off the front, we're going to return the thing off the front and put the rest of it. What's up, Drew? Free time for the weekend? A little time to yourself? That's always nice. Yeah. Here, let me let's do the following. I have a GPG key on a physical YubiKey so that I can do my verification for git commits anywhere. Basically. Any computer that accepts my YubiKey anyway. Well. Thanks for hosting, Drew. Oh, you asked a question that I totally missed. Was it normal for your professors to give extra credit? I don't really remember. But I think that was really common because people were bad at school, I suppose. Okay, so here, let me... His laptop is encrypted. Let's build $1 million cluster to crack it. No good. Yeah. Yeah. I like it. That's basically correct. It's kind of, I don't know, it was something that I thought was kind of interesting. So like a lot of my stuff is on the key. It's kind of nice. It's kind of cool. I mean, it depends, right? Like if you have lots of people that are failing, they need to do something. So if you can make them do extra work and their work is good, then, you know, it's worth boosting them up a little bit. Oh, right. Sorry, I lost my train of thought. Yeah, I used to do stuff like that. It would be like I'd keep a book, but so we are working on this one, and so this is for Strager. So yeah, you could just stare at this code and put it in your own interpreter and play with it if you want. But as far as I know, you can't write these differently. So it could be that I don't know what's wrong. Maybe I need maybe it's if it's under the keyword they won't find it. I like it. Maybe I need to like put this explicitly in parentheses or something. I don't think that would matter though. It should evaluate from left to right in this case. Okay, so are you shocked you majored in science but ended up doing coding? Not really, because like I'm a theorist. So right, I did theoretical chemistry, and you know, you basically require code to make that happen. Yeah, I have a different password for every single website. I actually do that with both my passwords and my credit card, as it turns out. I have a different credit card for every website I use. Capital One has a service for that. Can you hear all that noise behind me? If it's too loud, I can shut the door. Let me know. Yeah. I do something similar, Skybro. Okay, so anyway. The problem which carrot? I have a similar thing to Skybro. And then the problem is that, as far as I can tell, oh, here we go. Line 66. Do the right-hand side effect? Oh, I see what you're saying. I'm recursing through the right side before the left side. I want to recurse through the left side and then the right side. I see what you mean. That could be right. Let's see if it flips. Nice. Good call. That's clever. Yeah, so recurse through this. Yeah, for real. Strager's 300, 3000 IQ. I think he's right. Let's find out. Oh, I've kept too many things open. Okay. Reload. There it is. So it's broken again because we need to add the flip back. Do I have anything else? Good. Okay, so Vim source. Good call. So this recursion stuff ends up being really, really tricky. The good news is that you don't have to. Yeah, this time Strager broke it. Not so very sour. So yeah, now it's actually fixed. The implementation is fixed, and therefore we can write our flip correctly. We need to go fix that in the other place that we have that applicative instance. Very cool. Very smart as well. You've been using Haskell for a long time. It's quite clear. Here, I think. Wow, that's cool. That's very cool. That would have been very hard to prove, I suppose. We probably could prove it, but I'm not sure that I want to. Like, it's going to take me a long time to figure it out. Refactor your third pure. Third pure. Which one? Third pattern. 1, 2, 3. Line 79. Oh, right, because we're I see what you're saying now. Sorry. I was like, what is he talking about? And then me too, Sour. Me too. It's really hard. I'm glad I'm learning it now and not like. So I should point out this sometimes. Like I'm doing this really, really hard stuff now, so that when I encounter it in the wild, like when I start actually trying to do stuff, I can go reach for these tools when I know, like, will realize that I need them. So I like going deep before I start going, like, doing anything, because I want to know what I should be reaching for. And the problem with that is that you can go deep forever and never start any projects. So it's kind of a huge problem. At some point you have to stop going deep and start doing stuff and not get bogged down in the fact that you don't know everything. And I have a real hard time doing that. I've mentioned that before. Exactly. That's a nice way to say it, Altern, but again, it's like you can't learn every tool. You have to, at some point you have to say, okay, I'm going to use the tools I have to do something. Otherwise you're going to continue learning tools forever. I think that's how I see it sometimes. It's tough. Okay, I need to scroll up a little bit because is that going to be right? Pure.f.k? That would be cool. Oh. Okay, let's look at this again. So this is now supposed to be like this. It's not. So we've now pulled it out. So we need fmap here. No? Oh, okay, yes. Yeah, so you're super close. It's just that we need fmap because we've pulled out f. Yeah. So this wants us to use, sure. And then it's just this. Yeah. There we go. Yeah, so the reason we can do this for reference is just to make sure everyone's clear, because it's tough for me sometimes, is that what Strager was pointing out is that we have to recurse through the left side before we can recurse to the right side. Otherwise, we don't have the correct order for things like subtract. And the way you deal with that is basically... Oh, and also, another interesting thing is that this only comes up because of the way that we implemented our stack. If we implemented our stack at the end, then those would flip, I think. Or no, we just wouldn't require flip minus. It would still be minus. Everything would be correct. Never mind. Yeah. So we have to recurse through the left side no matter what. That's the way it is. For the evaluation piece, it's just the stack would still flip the sign on minus, essentially. That's all. So once we recurse through the left side, then we'll end up at some point with a pure, and then we need to recurse through the right side. So that's kind of how this ends up working. This is really cool. Yeah, it has to be left to right, right? Like this part has to be left to right. That's not gonna to switch anything. Yeah, it hurts. It hurts my head, for sure. This was really hard to implement. I'm glad that I got it really close. It wasn't quite right, but I was very close. And because I implemented that by hand. We figured that out on Thursday. Yeah, so what Strigger's pointing out is, again, this is happening because, okay, so the way freer works is that you get this monad for free, but typically what you're going to do, like in the operational style before, you saw that we just implemented the functor and the applicative in terms of the monad. So we can actually just implement both the applicative and the functor using the monad instance, and these will probably simplify. Like, we're writing the applicative and the functor separate from the monad, but it would probably clean things up actually if we just used the monad instance like we did for the operational style. And my guess is that if we looked at the implementations of these functions in here, we would find that they are in fact implemented that way. So let's find freer again, because the class, well, this is control monad freer, but is there a freer in here? It's just F, but this is different. This is not exactly freer, right? Because this is like you're modeling your effects as a type level list. This looks a lot like polysemi. How is this different than polysemi? Anyway, this shape looks similar to polysem. The only thing that's different is this is sem. Anyway, as far as I know. Okay, sorry, I'm getting sidetracked. Oh, nice. Let's check this out. Okay, so let's look at the, let me lift this up a little bit. Okay, so let's imagine F is very similar to ours. I think it should be. We can actually delete this line as well. Oh, whoops. We don't even need this line because it's implemented here. What are these E's? Oh, it's just impure. I'm stupid. It's a little different than ours. Yeah, she's very, very good at Haskell. Yeah, I thought it was really good. Got a lot of chat as well. I also like that one of the first Reddit comments was like, yeah, one of the first comments that was read was like, he ... you know, whatever. And I was like, well, they didn't read it, so freaking screen tearing. I don't know how to get rid of it. I don't know what's causing it, and I don't feel like digging into that. It drives me insane that I can see it on the screen, so I hope it doesn't hurt your eyes or anything. Anyway, what am I trying to do here? This is not, I mean, these are implemented using the functor, right? Yeah. Well, no, I don't see it in front of my screen, right? It's OBS that is capturing it. So like, it's something with OBS. I don't see it at all on my screen, other than the fact that in the preview window for OBS, and then in the preview window for stream, I see it. So I don't know what to do about it. Like something with encoding, who knows? All right. See you, Strager. Thanks for your help again. That was really, really awesome. It makes perfect sense once you said it, but you did. You solved world hunger. It was impressive. Nice. Looking, we'll wait for it. Okay. Yeah. Anyway, this is great. This is great. Oh, we gotta fix it over here too. Well, it's not really a fix. It's just, it's slightly better, arguably. Whoa. Well, it's still recursive, right? Because this side is still recursive. The problem is it was recursive in the wrong way. This is pretty awesome. I can't believe I actually finished this. I really wasn't thinking I was ever going to be able to do this. So the fact that we did, and I mean, obviously chat helped a ton, but you guys always help me, so. But I think this looks pretty awesome. I don't know what to do with this now. Like, what do I do with this? Try and explain freer monads to the layman? Is that what I do? It's like I gained all this knowledge, and now what? I guess I gotta write more code. I don't know. I don't know how to explain this. Yeah, now I just use it, right? But it seems like I should somehow share this. Like we collectively learned a lot about this. Like how do we share it with people that don't know how to do this? I mean, I'm sure there's already freer tutorials, but like I tried to read them before and it didn't make any sense. It seems to, yes, but does it need to? I don't know. Probably. Well, that's true. They could just watch the stream. That's a fair point. That's the knowledge. Speaking of which, I need to catch up on that. Okay, so what time is it? It's 1 o'clock. So maybe we'll start. What's the next chapter called? Oh, I still have multiple pages left. Okay, let's. Oh, and more exercises. I missed those last time. Okay, cool. So we got more to do. Wonderful. Let's keep going. We'll save this. Okay. So the conventional wisdom is that being inspectable, what the hell does inspectable mean? Is a property of initial style monads and free monads, but final style monads provide no such capability. But this is not true. That's so confusing. Oh, I see. Okay. Conventional wisdom is that that's true. But that's not true. We can inspect a final style monad by interpreting it into initial style and back again into final style. How strange. I'm just trying to read this to see if there's anything that I should be doing, but I'm not entirely sure. Okay, so this is like, it was connecting initial and final style, so we were talking about that earlier. So what's the difference between... Okay, I need to back up a little bit. We need to figure out... see you, Sour. Thanks for hanging out. Also pushed me to think about stuff, so I appreciate that. I gotta remember exactly how final and... Sorry, yeah, final and operational style connect. That's what I need real quick. Final style and operational style look exactly the same to me. Okay. Anyway, I think they're essentially the same. What's up, Pretz? How's it going? Few people left, some people coming in. Wonderful. We'll probably stream for, I don't know, it depends when my brother texts me. I gotta help my brother learn a little Python this afternoon. Oh, Jappy's live too. We got some followers on Twitter. Nice. Oh. Apparently I wrote today that I was streaming on Sunday on Twitter. Wonderful. Okay. I mean, yeah, obviously Python 5. AKA Haskell. Okay. So, apparently, do you think Python 5 would end up being Haskell? I don't know. So I always imagined that Python 4 would turn into basically just Julia. I don't think so. Like, I just assumed that that's where Python was going to end up. Like, everything is JITted. Because that Noomba thing got pretty popular, and so did Julia for that matter. So like if you just did that automatically for people, that would be pretty powerful. But I don't know what Python 5 would be, because I don't think Python 4 will ever be a thing. It's not clear to me. Anyway. So Oleg, obviously we got to talk about Oleg. He says, the work on final style interpreters provides a solution to this problem. I still don't fully understand the problem. Something about inspection, but I don't really know what that means. Inspectable. Not sure. So it says, oh, this has to do with the optimization. Okay. I get it. Hang on, let me show that function. RPN in free. I understand what's going on now. Okay, so at the end of Tuesday's stream. Oh, nice. You aren't the Oleg though, are you? That would be amazing. I didn't know that. I'll try to remember that, but I'm absolutely horrendous with names. Okay. So yeah, this optimized thing is all about being able to like look at the results to try and simplify the operations. And the problem here is that in initial style monads or free monads, you can't do this. Wait, what? Oh, it is a property. I see. In final style monads, you can't do this. Yeah. Okay. That makes sense. So this is like the idea. But apparently that's not entirely true. And the way you deal with this is just by you interpret your final style monad into an initial one and then back into a final one. And then what they're saying is Oleg pioneered a way to deal with this by keeping track. So it says each step remember the previous one. That's the idea. Maybe? I don't know enough about stacks and abstract machines to answer that question, unfortunately. So we need some context. Sorry. Last op Okay, and instead of like doing RPN in freer, we need freer. We're probably gonna want oh my goodness. RPN instructions. Not entirely sure what else we're gonna need. Instruction? Yeah. We probably need iStack and push and pop maybe? We'll see what else we need. But basically we're gonna try and remember the last operation apparently. So we're gonna have new type with context. Oh gosh, this is gonna get nasty. And it's gonna hurt my head, isn't it? Yup. What does this look like to everyone? Anyone see it? It's a writer. No, I'm out of coffee again. So sad. Okay, I need to drink more water. Yeah. Oh, well, yes, I guess it's more like a state, isn't it? It looks like a continuation either. Or, yeah, a reader with a state. Yeah, because a writer is just this. Wait, what is... Brain is, like, useless today. Oh, nice. Yeah. It's close to state. SAS. CAC. It is state. You're just embedded in... Yeah, it's state T. Why don't we just use state T? Okay, fun. So... MWA. M has to have a monoid. Okay. Yeah, right, because it's like logging. You're like accumulating a log, so that makes sense. Or something like that. I mean, it's not exactly that, but... So these are given to us, by the way, so I'm not really thinking about this too carefully. Context? Ah! Is that right? I mean, I'm gonna believe it. Okay. So sure. Oh, that's just the applicative error. So we need to implement the next exercise is implement those. So then we also need to implement instance monad m I stack m I stack with context last op m where. This works. Wait, what? Oh, right. So we're specializing our I stack pop and push, I guess. This is pretty weird code. We'll see if this compiles, but we're gonna have to put some extra stuff in here. C $. We're also gonna need tuple sections. Okay, so pattern bindings. Hang on. Oh, okay. Yeah, I'm missing some stuff. That's why. I was doing the wrong thing. So these need to be monad I stack. And then this is op push prime, I think. And then this is the tuple sections error. Yep. Okay, and then we have some actual errors. Okay, so this is the initial style not interpretation, the initial style encoding for pop and push. So what we're doing is we're taking our final style encoding, adding this last op thing for it to remember using this with context, and then that way I can write an optimized function using the initial style I stack monad. Yeah, something like that. I think my terminology is maybe close, but I'm not entirely sure. So here it was saying we could use lambda case. Seriously? I love lambda case, it's great. Did I check that I had a text message? Okay. My brother said he would probably text me around 2, so. Right. So now we need to write our instance for applicative with context last op m. And I presume that that will be there. Okay, so all we want to do is get there. And so this is really exercise 1319. Okay. So our F should be an A to B, and this should be the with context. Okay, so our context is something like this. We might need this lambda case again, I guess. I don't think that's right. It's probably going to be something like this. So what's X prime now? Do this, see if it even compiles. I don't have a, oh, right. Context do. Yeah, thread the state through. Thread the state through. I just need to get at this A. So, is it supposed to be like... And then this gives me A, right? Yeah, so then I can say we want to pure f x like that. X prime. Right? Something like this. I think this is right. So, given the new context, for whatever reason this feels backwards, but I don't know even what that means. So how do I put backwards into... I think it's correct, but it feels like I'm not threading through the context, because this is like the old context, right? Not the new context. Does that make sense? This is the new one, you think? Okay. I guess it is, right? Because we're actually applying... Right, X is what again? It's a with context, so it requires... Okay, yeah, I think it's fine. Unclear? I don't know what you mean by that, Striger, sorry. Oh, that's true. I've probably implemented state T multiple times. I just... Oh, okay, uncle. I get it. Sorry. I was So this is the same as this. And we can actually delete this. All right, so here... we need to get... Does it matter what the last operation is here? I don't think it does. So this is how we get the inspection. So here it does not matter what the last operation is. This last op. That's the context we're threading through. It's the state. So it doesn't matter what it is when we're implementing this. It does matter when we're implementing this, though. That's how we're getting this inspection back. Yeah, like being able to figure out what the last op was matters there, but it does not matter when we're implementing the applicative. Yeah, it is just shaped a little different. Okay, so anyway, oh, did fat. Thanks for the follow. Are you ready? So, did fat is my brother. So I think I want to finish this before I stop, Nick. So just give me 2 seconds. You can watch me struggle. If this doesn't make any sense, I'm sorry, but it is kind of how it goes. All right, so we're gonna have some context, and then we need to get our function first, probably. So it's gonna be like f prime context prime, and f of unc f context, and then we're gonna have basically x prime, let's just call this x context x context prime, and something like this, I think. Maybe? So I think this is probably correct. But yeah. Okay, so this is where I want to stop. And yeah, we did 3.5 hours today, so that's pretty good. We made up for our missing Thursday, so I'm pretty happy about that.